the structure of atom. We have started the new chapter, that is structure of atom. Okay. In that chapter, we have started with the fundamental particles of atom. That is the fundamental particles of atom. That is the proton, neutron, and electron. So the discovery of electron, proton, and the neutron, its properties that we have discussed. Then also the model of an atom. So different scientists have given some different model. The first one is a J.J. Thomson model, where he has explained that the atom is it is just like a watermelon, in that protons are distributed and electrons are also distributed, and mass is uniformly distributed. That is his concept. Then the next model was given by Rutherford. He has made little more development in that, and he found that protons are not distributed. They are concentrated at a center, or it is called as a nucleus. So protons are together and they are at a center, and there is large number of empty space in that atom, and electrons are revolving around the nucleus. So that is a model. He has given a nuclear model of an atom. But meanwhile, Max Planck, he has also given some idea that when the charged particles are moving, so they lose the energy, and automatically, as per the Rutherford model, when electrons are revolving around the nucleus, so it is a charged particle, electron is having charge. When it is moving under electrostatic force of attraction, therefore it loses energy and it will fall into the nucleus. So therefore that there is a contradiction, and also he is from Rutherford model. We are not able to explain the stability of an atom. Atom is unstable. That cannot be explained by using the postulates or the points on the Rutherford model. Then the next one more is Rutherford. He has not given the idea, or he has not mentioned how the electrons are distributed. Okay, for hydrogen it is only one electron, but when you go for a higher atomic number, there are a number of electrons are also increases. Then how the electrons are distributed, all the electrons are together, or how they are their positions, so that is not mentioned. So these are called as some limitations or drawbacks of a Rutherford model. So the next model is developed by the Nobel laureate Niels Bohr. So before going to the Niels Bohr model, let us take some more ideas what you have already studied in high school. That is isotopes. Okay, so isotopes, isobar. Then also to understand that Bohr's model, you have to learn some more terms, that is electromagnetic radiation. Okay, so that we are going to study today. So we know that is atomic number. Atomic number. So it is normally denoted by Z. What do you mean by atomic number? It is nothing but the number of protons in an atom is called as the atomic number. So atomic number is nothing but the number of protons in an atom is called as the atomic number. And we know the number of protons is same as the number of electrons. So therefore, atomic number is also nothing but the number of electrons. So number of electrons is number of protons. So therefore, you can say that the atomic number is nothing but either number of protons or number of electrons. So that is denoted by symbol Z. Next one more we are having, that is a mass number. Mass number, it is denoted by the symbol A. So mass number, it is also number only. It is not a mass of Dravya Rashi. Here a mass number. It is a whole number only. It is not a fraction. Just like atomic number is also whole number. Okay, Purna Sankhya. Mass number is what? It is number of protons plus neutron. Number of proton plus neutron is called as a mass number. Proton and neutron is so they are present in the nucleus. So therefore that is also called as a nucleons. Nucleons means it is a proton and neutron. ಎರಡನ್ನ ಸೇರಿಸಿ ನ್ಯೂಕ್ಲಿಯಾನ್ಸ್ ಅಂತಾರೆ. So mass number is nothing but it is the number of proton and neutron. Okay, so mass number is nothing but number of proton and neutron. So based on this, if you know proton, mass number and atomic number, we can calculate the neutron number of neutron also we can find out. So there is a formula, or we can write that if x is an element. X is an element, right? Normally we will write the atomic number is here and mass number is number. So x is an element, z is an atomic number, a is a mass number. Okay. So by the knowing of this concept, okay, we can take some example or some numerical problem to get a means of finding the number of protons, neutrons, and electrons. Follow here. Atomic number ಅಂದ್ರೆ ಏನು? Number of proton. Mass number ಅಂದ್ರೆ ಏನು? Proton ಮತ್ತು neutron. Okay. So ನಮಗೆ atomic number ಗೊತ್ತಿದೆ, mass number ಗೊತ್ತಿದೆ, ನಾವು neutron ಕಂಡುಹಿಡಿಯಬೇಕು because proton value ಇದೆ. Okay. So we can write one formula here, that is number of neutron equal to what? Number of neutron equal to mass number minus atomic number. Okay. Number of neutron you know is, so other than we want you to make a proton plus neutron is a, that is the mass number. Other than number of protons is the number of neutrons. Okay, so this is the formula you have to remember. So sometimes we will give the formula of this element, mass number and atomic number. We have to find out the number of neutron. Okay, let us take some example on this. Calculate the number of proton, neutron, and electron in the following. Calculate the number of proton, neutron, and electron in the following. First one, carbon 613. Second, uranium 23919. Third, iron 2656. Fourth, chlorine 1735. Fifth, strontium 3880. So we have to find out the number of proton, neutron, and electrons. So we know here. So ಕೆಳಗಡೆ ಬರೆದಿದ್ದು Z. A is the Z is the atomic number, A is the mass number, and atomic number is same as the number of proton as well as the electron. So mass number is nothing but it is the number of proton plus neutron. So therefore number of neutron equal to A minus Z. Okay. So I will take out first two example. So carbon 630. Okay. What is this? 6 means number of okay. So I make like this. You can do electrically. Element, number of proton, number of electron, number of neutron. So carbon 613. 6 is what? Number of proton because atomic number. This atomic number, so proton same. Yes, proton is as the electron is because it is a neutral. Atom as a whole is a neutral. Now what is the number of neutron is what? A minus Z. A means this. So Z 13 minus 6. Number of neutron 13 minus 6. That is a 7. So next one uranium 92 to 39. So atomic number is same as a number of proton. That is 92. Yes, the proton is there as a electron 92. Now what? Number of neutron is a mass number minus atomic number. 239 minus 92. 9 minus 2 is 7. Then 13 minus 9, 4, 147. So like this, you have to calculate the remaining. Okay. So hope you have followed that is what is the atomic number, mass number. See, these are numbers. You will point them by algo. Okay. And this is one of the important formula. Remember, number of neutron equal to A minus Z. So you work out the remaining. Okay. So next concept is isotopes and the isobars. So already you have studied isotopes. Isotopes are here at the isotopes. Okay. Isotopes. Yes, isotopes means so you are studying the isotopes of hydrogen, that is a protium, deuterium and a tritium. So means having the same atomic number but different mass number. Z same iruತ್ತದೆ, A change ಆಗ್ತಾ ಹೋಗ್ತದೆ. So that is called as a isotopes. Isotopes are nothing but atoms having same atomic number but different mass number. Different mass number. Example, hydrogen 11, that is a protium. Then hydrogen 12, deuterium. Then hydrogen 13, that is a tritium. So this is some example. Similarly, chlorine 1735, 1737. Then now we have taken in the first chapter carbon isotopes. So carbon 12, 13 and 14, the atomic number 6. Similarly uranium, so uranium 92, 236, 239 like that. So there are many isotopes are there. So this is known as a isotopes, where having same atomic number but the mass number changing. See, that is same 17, 17, but here 35, 37. Okay, so these are called as a isotopes. Next is a isobars. Isobars means what? Reverse, ulta. Having a different atomic number, same mass of number. So they are called as a isobars. Atoms having same mass number but different atomic number. Okay. Example, carbon, one of the isotopes of carbon is of atomic number 6 and mass number is of 14. One of the isotopes of carbon. So mass number 14 ಇರುವಂತದ್ದು ಇನ್ನೊಂದು atom 97. So here they are different, atoms are different. Atoms having the same mass number but different atomic number changes. And the same atoms in the atoms itself is different. So isobars are having different atoms. Okay. Atomic number different, mass number same. So that is called as the isobars. Okay. Such examples you can give for isobars. So this is about the isotopes, isobars, and the finding atomic number and the mass number. Okay. Now let us go for the one more concept, that is I told you, to understand Bohr's atomic model, we require some knowledge of electromagnetic spectrum or electromagnetic radiation. So what do you mean by electromagnetic spectrum or radiation? ವಿದ್ಯುತ್ಕಾಂತೀಯ ವಿಕಿರಣ. ಅಷ್ಟೊಂದು ಓದಿದ್ರಿ? Okay. So or electromagnetic waves, ಅಲೆಗಳು. So when a charged particles are moving or in the acceleration, so they produce electric as well as a magnetic. ವಿದ್ಯುತ್ ಮತ್ತು ಕಾಂತೀಯ, ಕಾಂತ ಅಂದ್ರೆ ಅಯಸ್ಕಾಂತ, ಮ್ಯಾಗ್ನೆಟ್. ವಿದ್ಯುತ್ ಕಾಂತೀಯ ಅಲೆಗಳು ಅಥವಾ ವಿಕಿರಣ, they are having a electric as well as a magnetic field. Okay. So that type of waves or radiations are called as a electromagnetic radiation. So Maxwell has mentioned that when charged particles are moving, so they lose energy. That energy is in the form of a radiation. So it is a electric field as well as a magnetic. So they are alternate and they are perpendicular to each other. If this is a electric waves, this is magnetic wave. So idu ee reeti mundake hogutade. This will move like this. So you have to imagine that is a three-dimensional picture. Okay. One wave is moving in this direction. That is up and down. Another wave is moving in this direction. That is a front side and a back. You have to imagine this three dimension. This mundakide, this hindagide, this mele keಳಗಿದೆ. So this type of waves. So that is a electromagnetic radiation. Okay. So they are mutually perpendicular. ಒಂದಕ್ಕೊಂದು ಲಂಬವಾಗಿರುತ್ತೆ. One will move like this and another will move like this. Okay, up and down. This is the front and back like this. So such electromagnetic radiations are produced, and they are having different types of electromagnetic radiations you have studied. That is gamma rays, alpha rays, gamma rays, X-rays, radio microwaves, UV, IR. Okay, all those terms are nothing but electromagnetic radiation. And they are having the speed of all these waves or radiations are a constant. It is the velocity of light. That is what is the velocity of light? It is 3 into 10 raised to 8 meter per second. This is constant. And they move in a vacuum also. So vacuum relation also say they will move, means they does not require any medium. ಮಾಧ್ಯಮ ಬೇಕಂತಿಲ್ಲ, ನಿರ್ವಾತ ಪ್ರದೇಶದಲ್ಲಿ ಅದು ಮೂವ್ ಆಗುತ್ತೆ. So that is a electromagnetic radiation. And here we are going to get this velocity of light is a normally we get as c. What is the c equal to? C equal to nu into lambda. What is nu? Is a frequency. Lambda is a wavelength. C equal to nu lambda. One of the important formula you have to remember. So electromagnetic radiation, that is what we are taking, that is gamma rays, X rays, UV rays, IR rays. So they are having the same velocity. Only the change is found here. One HER will come back out. Okay. So now let us list out those electromagnetic radiations. Okay, just to get idea. Already you know better in high school. So just once again recall that. Then we can go for further. That is Bohr's model. Okay. So here we are going to mention some of the things. That is what we mean by frequency and rate, lambda, wavelength and rate, wave number and rate. So that we have to study here, or that we have to remember. Okay. So the electromagnetic radiation. So electromagnetic radiation, these are the electromagnetic radiation. It is gamma rays, X-rays, UV, visible, IR, microwave, radio waves. So you will have electromagnetic radiations here. So here I told you I have given that is C equal to mu into lambda. So velocity same, mu ಮತ್ತು lambda change ಆಗ್ತಾ ಇದೆ. So that is if you observe here. So frequency decrease ಆಗ್ತಾ ಹೋದ್ರೆ wavelength ಹೆಚ್ಚು ಆಗ್ತಾ ಹೋಗ್ತದೆ. It is minus 10 raised to minus 16 ಇಂದ 10 raised to 8 ಅಂದ್ರೆ increase ಆಗ್ತಾ ಇದೆ wavelength. ಒಂದು increase ಆದರೆ ಇನ್ನೊಂದು decrease ಆಗಿದೆ. ನೋಡಿ 10 raised to 24 ಇದೆ, ಇಲ್ಲಿ 10 raised to 6 ಬಂತು. So means to balance this, ಇದು constant ಇರಬೇಕಾದ್ರೆ ಒಂದು HER ಒಂದು ಕಡಿಮೆ ಆಗುತ್ತೆ. Okay. So that is this type of arrangement, that is writing the electromagnetic radiation in the increasing order of wavelength is called as electromagnetic spectrum. Okay. So in the case of the energy of the rays is directly proportional to frequency. Frequency HE is energy HE. Gamma rays are high energies, whereas radio waves are lower energy. Okay. So the energy decreases. So here normally we have to remember this visible region, not whatever we can see that wavelength. So visible region is at the frequency, it is a 10 raised to 15 hertz, and wavelength is a 400 nanometer, nm, nanometer. Idella meter alli idave. Okay, here is nanometer, 400 nanometer to 750 nanometer. This is the visible region. ಅದರಿಂದ ಮೇಲ್ಗಡೆ ಇರೋದು ಯಾವುದು UV, X-ray and gamma ray. ಅದರಿಂದ ಕೆಳಗಡೆ IR, microwave and radio waves. Okay. So these are the electromagnetic radiation. So I told you electromagnetic radiation, electric as well as magnetic. So they are mutually perpendicular. ಒಂದಕ್ಕೊಂದು ಲಂಬವಾಗಿ ಇರ್ತದೆ. Okay. And it does not require any medium. ಯಾವುದೇ ಮಾಧ್ಯಮ ಬೇಕಾಗಿಲ್ಲ. Okay. So these are the electromagnetic radiations. So next is what do you mean by wavelength? Lambda wavelength. So wavelength, then frequency and wave number, that we have to learn. So when you consider a wave, if I draw this, if I start from here and if it ends same point here, means this length is called as a wavelength. Wavelength ಅಂದ್ರೆ ಏನು? ಇದರಿಂದ that is lambda into this length, how much this length is from here to here, that is called as a wavelength. Or this is called as a crest, and this is called as a trough. It is the distance between a successive crust. E crust is in the ಇನ್ನೊಂದು crust ಬರಬೇಕಾದ್ರೆ ಎಷ್ಟು distance ಇದೆ, so that is the difference. Or trough, it trough to this trough, next system. So this distance, so that is called as the wavelength, that is lambda. Wavelength means what? It is the distance between two successive crust or trough. Crust ಅಂದ್ರೆ ಮೇಲಿನ ಭಾಗಕ್ಕೆ crust, ಇದು ಕೆಳಗಡೆ trough. So that is about the wavelength, lambda. Normally it is denoted by the SI unit of a length is what? Meter. But practically now meter ಅಂತ ಹೇಳಿದ್ರಲ್ಲ wavelength, it is in terms of Armstrong unit. 1 Armstrong unit equal to 10 raised to minus 10 meter. Armstrong unit को nanometer लिया जाता है normally. Okay. SI unit is a meter. That is known as a wavelength. Next is a frequency. Frequency is what? So it is nothing but 1 by time. That is the number of waves per second. How many waves are passing in 1 second? That is called as a frequency. Okay. Wavelength is denoted by lambda. It's SI unit. SI unit is a meter, but a practical unit is a either Armstrong unit or nanometer. Okay. It is nothing but the distance between two successive crust or trough. Next is the frequency. Frequency is a nu. Okay. SI unit is a hertz. Hertz. Okay. Or cycles per second. 1 hertz and 1 hertz is nothing but 1 cycle per second. It is a time. 1 minute, 1 second, how many waves are passing? So that is called as a frequency. Okay. Next, one more word we are having on. It is a wave number. Wave number. It is denoted by nu bar. Wave number ಅಂದ್ರೆ how many waves are there in a given length? That is called as a wave number. Suppose here this is one wave and this is another wave, so from here to here. This length, how many waves are there? There is a 1 and here is 2. This is the wave number of this wave is a 2i. Suppose if I draw one more wave, how many waves are this? So here to here, that is 1, 2, 3, 4, 5 and half. So it is a 5 and half. So wave number is a 5 and half for this, and wave number for this is a 2. It is the number of waves per given length per meter. So that is called as a wave number. See the difference between a frequency and a wave number. So wave number is nothing but, so nu bar is equal to 1 divided by lambda. For a given length, how much waves are there? For a given length, for a given 1 meter, what is the wave length, how many waves are there? That is nothing but a u bar, that is the wave number. Okay. So these are the things we require for further to understand the Bohr's atomic model. Ali nಮಗೆ ಬರ್ತದೆ wave length ಬರ್ತದೆ, frequency ಬರ್ತದೆ. Okay. So radiation takes place, energy is released in the form of a radiation, that is a quantum of energy, that is a photons. So spectrums ಬರ್ತದೆ, ಅವಾಗ wave length, wave number, then frequency ಎಲ್ಲ ಬರ್ತದೆ. So for that, to understand that, we require some idea of electromagnetic radiation. Okay. So next class I will take about that Bohr's atomic model, one of the important concepts. Okay. Thank you.